Welcome to EduNinja. This is an exam concept lesson. Today, we are studying IGCSE Computer Science for CAA. Our topic is sound representation. We will focus on sample rate, sample resolution, and compression. Concept first, then real exam questions. Key Concept 1. How sound becomes digital. A computer cannot store a continuous sound wave directly. Instead, the wave is sampled at regular time intervals. Each sample is converted into a binary value that the computer can process. Remember, sound is sampled first, then the sample values are stored in binary. Quick check. What happens to the sound wave before a computer stores it? It is sampled. Key Concept 2. Sample rate. Sample rate is the number of samples taken from a sound wave each second. A higher sample rate records more detail from the original wave, so we can compare fewer samples with many more samples. Higher sample rate improves accuracy, but creates a larger sound file. Remember, higher sample rate means higher accuracy and a larger file. Quick check. What does sample rate measure? Samples taken per second. Key Concept 3. Sample resolution. Sample resolution is the number of bits used to store each sample. More bits give more possible amplitude values for the sound. That means the recorded values can be coarse or more precise. Higher sample resolution improves accuracy, but creates a larger sound file. Remember, higher sample resolution means more accuracy and a larger file. Quick check. What does sample resolution measure? Bits per sample. Key Concept 4. Compression. Compression reduces the amount of data needed to store a sound file. A smaller file needs less storage space and less bandwidth. It can also be transmitted more quickly. The idea is the same sound represented with less data. Remember, compression means a smaller file and easier storage and transmission. Quick check. Why is sound compressed? To reduce file size. Real Exam 1. 2 marks. Define sample rate and sample resolution. Sample rate is the number of samples taken from a sound wave each second. Sample resolution is the number of bits used to store each sample. The key distinction is samples per second versus bits per sample. Now identify the compression type and the packet header data. Reducing the sample rate and sample resolution is lossy compression. For a packet header, valid examples include an IP address and a packet number. Remember that packets can take different routes, arrive out of order, and be reordered at the destination. Real Exam 2. 7 marks. Explain how analog sound becomes binary data. Start with a microphone recording the sound. The wave is sampled, its amplitude is measured, and each sample is assigned a binary value using a chosen sample rate and sample resolution. To improve quality, increase the sample rate and increase the sample resolution. Finally, explain why lossless compression is suitable here. The student needs to edit the original sound file and keep the highest quality. Lossless compression retains the original information, so there is no permanent loss of sound quality and the file remains editable. Before the final check, use these scoring tips for sound representation. 1. State the sampling process in order from the microphone to binary values. 2. Keep sample rate and sample resolution separate. Rate is samples per second. Resolution is bits per sample. 3. For packet switching, include header data such as the IP address and packet number and explain routing. 4. Choose compression by checking quality and editing. Lossy compression is permanent. Lossless keeps the original information. Final check. Microphone, sampling, binary values, packet headers, and compression choice. Keep practicing with real exam questions on EduNinja. Study sound representation topic by topic. Follow step-by-step solutions. Build smart papers. And use revision notes when you need a quick recap.